Welcome to Understanding Math with Professor Seff. It is our goal that all students should understand math properly. Unfortunately, many students get lost in the early grades, often because mathematics seems like some cryptic, unintelligible series of steps or motions or ideas that do not seem connected, and they just try to memorize so they give up. Unfortunately, many teachers also have the same idea. The truth of the matter is, math is quite understandable and anybody can do it. Our goal is to see to that both students and teachers have a proper understanding. Teachers, of course, have to have a proper understanding so the students can. So we want now to explain some basic ideas that, if they are properly understood, will be the key to understanding math. The first concept we're going to explain by example. Consider the following scenario. Suppose there is a house with two rooms. Here are the two rooms, labeled A and B. And there's a doorway between the two rooms. Now there is a person in room A. And as you can see, he's a happy person. He's happy because he understands math. Now this person is going to change rooms when a bell rings. We're going to ring a bell. Every time the bell rings, he moves to another room. He will start off in room A. The bell rings, he moves to room B. The bell rings again, he moves back to room A. Every time the bell rings, he changes rooms. So we're going to give you a little problem to think about. Assuming he starts in room A, and the bell will ring 3 times. What room will he end up in? Think about it for a second, and what's your answer? You may turn this video off if you wish, in order to give yourself more time to think. Hopefully this is not a hard problem. The way to do it is he starts in A, the bell rings once, he's in B, twice he's in A, third time he's in B. So if the bell rings 3 times, he's in room B. And that is certainly the correct answer. Let's give a slightly more difficult problem. Suppose the bell rings 250 times. We're not going to ring it 250 times because it takes too long. But you figure out what room he will be in, assuming he's starting in room A. Ready? Think about it. If you wish to turn off the video to think more, by all means do so. But we'll give the answer in just a few seconds. What's the answer? The answer is he will be in room A. Some students have no trouble with the first problem, but they have trouble with the second problem. Those who do the second problem often say, aha, they have a tremendous insight. They say, look, A is an even number, so he is in room, 250 is an even number, so he will be in room A. What are they saying? They're saying as follows. 1 ring is B, 2 rings is A, 3 is in B, 4 is in A, 5 rings is B, 6 is in A. They see there's a pattern. Odd number of rings is in room B, even number of rings is in room A. They see the pattern, they say it must be that odds are in room B, evens are in room A, and that is indeed correct. This is an important concept they have just discovered. Now, what is the difference between the 2 ways in which this problem had been solved? The first problem people solve by going back and forth, either in their minds or they actually take a finger or a pen and go back and forth. Well, that's too long and too hard to figure out 250 rings. What they do in this case is they actually think deeper about it and figure out a pattern. So what's the difference in these 2 types of thinking? The first type of thinking I call concrete thinking, and the second type of thinking I call abstract thinking. Now, all thinking is abstract because it takes place in the mind, but the first type of thinking is not as abstract as the second type because the visualization is associated with something physical. One either moves a pen or pencil or one's finger, or one visualizes the motion and going to move between room A and B. The abstract, no one is thinking about moving a finger or a pencil. One is thinking about concepts, patterns, logical concepts. This way of thinking is what I call abstract thinking. It may be compared to the concept of abstract and concrete nouns. We all learn in grade school there are nouns that are names of persons, places, and things. It's possible you also learn there are some nouns that are called concrete nouns and some are called abstract nouns. What are concrete nouns? Concrete nouns are the names of things we can see or touch or have physical reality, like pen, bell, paper, These are things we can see or touch. Even things we cannot see or touch, such as sound, which is not touchable but certainly hearable, audible, is something that is a concrete noun. Why? Because it's detectable by the five senses. Light is something we can see, we can't hear it, but it's something detectable by the five senses. Anything detectable by the five senses, even air, which is invisible but can be felt by means of a breeze, is something that's a concrete noun. It's made out of molecules. Now, light is not made out of molecules, but it is detectable, and therefore it is considered a concrete noun. There are nouns, however, that are not concrete. They are real things, but these things have no physical reality. For example, knowledge, understanding. Knowledge and understanding are things that exist. They exist inside a person's head, not in something that is made out of molecules. Similarly, emotions such as love, hate, anger, all these emotions exist in one's heart, metaphorically. They're real, very real. Much of our life is based on such things as love, knowledge, understanding, or hatred or anger, or other emotions, or other pieces of knowledge, information. But all these things, knowledge, information, emotions, all these words are not concrete nouns, they're abstract nouns. In mathematics, we like to do abstract thinking. It's important to realize that in mathematics, abstract thinking is very useful and very important, and often the main idea that's used. To go to abstract thinking, we may have to start with a simple concrete case, such as the case of just 3 bell rings as opposed to 250. But once we can generalize and work in abstract terms, the problem becomes easier. Abstract thinking has many advantages. One of them, most obvious, is it's quicker. Secondly, it gives us a deeper understanding of the problem. We can work other problems like this. In fact, we can even work other problems that don't seem like this, but that on an abstract level are indeed perhaps similar, and we hope to give one or two later.